Hello, welcome to a video that discusses problems 25 to 32, 41 through 46, and number 56 from the summer assignment. So the summer assignment is right here on my screen. So we're going to again talk about 25 to 32, 41 through 46, and 56. And our quiz next week will deal with graphing problems like those problems I just mentioned from the summer assignment. So without further ado, let's get started. So for number 25 to 30, you're asked to find the domain analytically without a calculator. Try to find the range by thinking about the function's behavior, again without a calculator, and do your best sketch without a calculator. And then of course, use the calculator to confirm for part D. Well, our quiz is going to be no calculator allowed, so no calculator. So let me show you how you can do these with confidence. So we'll start with number 25. So for number 25, you have y equals 4 minus x squared. Now, if you go to our worksheet, worksheet 7, where is it? We see that the parent function is a quadratic, or like y equals x squared, which should look like that. So it's pretty clear compared to y equals x squared, we're going to reflect about the x-axis and shift 4 up. That's because the equation 4 minus x squared is no different than saying negative x squared plus 4. The negative causes the reflection, and the plus 4 on the outside causes the shift of 4 up. So here's y equals x squared. So if I reflect about the x-axis and shift 4 up, I'm going to expect my vertex to be at 0, 4. And if I take another point like 1, 1, reflect about the x-axis, and that's at 1, negative 1, and shift 4 up, now it's going to be at 1, 3. And so my graph looks like that. The domain here is all real numbers. And of course the range will be from 4 on down to infinity. Or sorry, negative infinity to 4. Because it does go down forever, but stops at 4 at the high point. So that's how 25 looks. Now, let me open up a new screen for number 26. Y equals 2 plus root 1 plus x. Now y equals root x, we know should look like this. Point at 0, 0, and point at 1, 1. So now in this case, this equation is no different than saying the square root of x plus 1 plus 2. That's a shift of 1 left and 2 up. Remember, the plus 2 is up, the plus 1 is shift 1 left. So the point 0, 0 has to go 1 left and 2 up. So now it's going to be at negative 1, 2. Again, think about it. Take 1 away from x, that's negative 1. Add 2 to y, that's 2. Likewise with 1, 1, take 1 away from x, add 2 to y. Now we're at 0, 3. You can even plug in 0 for x and see for yourself it is 3. With a domain that is negative 1 to infinity and a range that's from 2 to infinity. And of course 2 and negative 1 are included. Let's look at 27. So for 27, we have y equals 1 over x minus 2. So you may want to pause the video and see if you get the same thing as me. And do compare to 1 over x, which you should know looks like this. And of course, asymptotes on the x and y axes. So x equals 0, y equals 0. So you may want to pause the video, see if you get the same thing as me. If you said shift to right, congratulations, you got it correct. And that's the only transformation that happened from the parent function, y equals 1 over x. And again, if we look at our worksheet, 1 over x is right there, where domain and range are as indicated. Okay, good. That makes me a little bit happier. I was like, I wish we didn't have to see it the whole time. Okay, next one. Oh, domain range, sorry. Got a little distracted there. So domain here is from negative infinity to 2, and 2 to infinity. So 2 is not included. Should be parentheses there, sorry about that. And the range will be from negative infinity to 0 and 0 to infinity, because the parent function had the same thing. We didn't shift the graph vertically, so the range stays the same. Okay, 28 is y equals cube root of x minus 3. So hopefully you remember that y equals cube root of x. Looks like that. Also, if you think about it, it is a power function. And we have talked about power functions. Whenever your exponent is between 0 and 1, you're going to expect the curvature like you see in the first quadrant, kind of like a square root function in a way. And because you're odd rooting, your denominator is odd, we are allowed to plug in negative values for x. So the domain is all real numbers and range is all real numbers for the parent function. Now again, we're asked to graph cube root of x minus 3. Hopefully you recognize that's a shift of 3 right. So if I look at like a point like 0, 0, as well as a point like 1, 1, so now we have a point at 3, 0 and a point at 4, 1. And it follows kind of the same path. Domain range, negative infinity to infinity, or essentially all real numbers. All right, 29. Ooh, 29 is interesting. Cube root. Sorry, fourth root. I can't believe I said that. I'm a little tired. My apologies. And we're going to compare it to the fourth root of negative x. Okay, so let's start with the fourth root of x. This is the same thing as saying x to the 1/4 power. So again, in the first quadrant, the curvature will be similar to a square root function or a cube root function, because your exponent's between 0 and 1. So it's like a power function. And you can't fourth root negative numbers, so you're going to have to leave the answer like that. There's definitely a point at 0, 0. There's definitely a point at 1, 1. Now, what does this do, the negative on the inside? If you thought reflection, that's fantastic. More specifically, you don't reflect about the x-axis, you reflect about the y-axis. And here's the reason why. No pun intended. Anyway, if you plug in 0, so that's 0, but you can't plug in 1 for x. But you could plug in negative 1 for x. And of course, if you do that, negative 1 is 1, 4 through 1 is 1. So essentially, it's like you're multiplying your x values by negative 1 when you compare it to the parent function. Domain is going to be from negative infinity to 0. 0 is included. And the range is, of course, from 0 to infinity. And then lastly, 30. Y equals square root of 4 minus x squared. Now hopefully you realize this is a semicircle. So it's a matter of recognition. And here's the reason why. If you were to square both sides, move x squared to the other side, you would get the equation of a circle, which of course has a radius of 2. That's a really not great circle, but you know, radius of 2, center 0, 0. So that's essentially what's happening here. Now, the thing is that when you were to get y by itself from x squared plus y squared equals 4, it's actually plus or minus 4 minus x squared. But because we have the positive part, the positive square root, it's only going to be the top half of the semicircle. Because y can never be negative. When we look at that equation there. So that's what we have for 30. Domain, of course, from -2 to 2. The range from 0 to 2. So these are functions that we tend to see often in this course. If we take a look at 31 and 32. So dealing more with transformations, hopefully you realize we have to go 3 right, 2 up, and of course, they reflect about the x-axis. And actually, to do this in the right order, 3 right, then reflect about the x-axis, basically follow the order of operations. You know, what does x see first? You got to subtract the 3, that's 3 right. Then you do the absolute value. Then you do a negative afterwards. That's a reflect about x-axis. Then add 2 is the last thing that happens, which is a shift of 2 up. So when we compare it to that guy, shift 3 right. So you get 3, you know, if you look at the vertex, 3, 0. You reflect that about this x-axis, 3, 0, still at 3, 0. Shift 2 up. But then when I look at the point 1, 1, shift 3 right, so it's a 4, 1. Reflect about the x-axis, 4, -1. And shift 2 up, it's a 4, 1. And just ensure symmetry, you have something like that. And there's a graph. Domain, all real numbers. Range, it goes from -infinity to 2. Piecewise. This one should be pretty simple. You're graphing y equals 1 when x is less than 0. Then you're graphing root x until you get to 4 for x, which has a y value of 2. And that's not included, should be a hole there. 0 is included for the square graph, but not for the y equals 1 graph. And then 1/2 x minus 1, when x is 4, plug it in, you should get 1 included. Plug in 6, it should be 2. And so it's just the slope of 1 over 2. So there we go. Okay, these bad boys. You should know how an exponential function looks. For 41, y equals e to the x. Don't let the e freak you out. E is roughly a number that's about 2.7. If you make a quick table, x is 0, y is 1, x is 1, y is 2.7, or just e. So it would look kind of like this. And it's something that increases very quickly and has a horizontal asymptote at y equals 0. So clearly, c goes to 41. Now if you look at 43, remember, when there's a negative next to x, it's reflect about y-axis. Well, which one reflects about the y-axis for us? Clearly b. Plus, if you were to plug in like -1 for x, you get e, you know? There we go. And 0, of course, you still get 1. Now 0.5 to the x, 45 is kind of interesting. That's going to be exponential decay. That's because when x gets larger, y gets smaller. But everything stays positive. So in that case, yeah, it says here it's possible more than one function could look like one of the graphs shown. So that's going to be b again. So it's interesting. 43 and 45 take on the same shape. For 42, this is exponential growth because your base is larger than 1. But we reflect about the x-axis because there's a negative out in front. So in this case, it's going to be more like a. Because notice that a is like c, but just reflected about the x-axis. So 42 is a. Now we're down to 44 and 46. Now for 46, I'm going to need kind of a new thingy here. Y equals natural log of x, which hopefully you know means y equals log base e of x. And hopefully you know how to transform, which is x equals e to the y. This is the inverse of y equals e to the x. Well, y equals e to the x, you know, again, was that, right? So the inverse, you switch x and y, right? 1, 0. And E1. E is about 2.7. So notice how those are reflections about y equals x, which is what we expect for inverse functions. So it's 1, 0, E, 1. So that's definitely going to be like D. And the other thing to take note is that you're also going to have a vertical asymptote at y equals 0. Whereas for exponential functions, of course, we have a horizontal asymptote at y equals, sorry, I meant to say x equals 0. My apologies. And then, you know, 44 is kind of lonely, but it's going to be E, and I'll explain why. So first of all, it's like 2 to the negative x power. It's probably the best way of looking at it. Well, 2 to the x is easy. It's that. So 2 to the negative x is that. You reflect about the y-axis. We've seen this a few times already in this video. And then negative 2 to negative x, you reflect that bad boy about the y-axis. That's what's going to look kind of like E. It's kind of weird. And that's what happens there. So basically I took what y to 2 to the negative x was and reflected about the x-axis. Okay, lastly, 56. So now we've seen y equals natural log of x, which now we know is this. Vertical asymptote, x equals 0, got that right now. Crosses through 1, 0, and also crosses through E, 1. So, shift four right. So instead of 1, 0, now we have 5, 0. And instead of E1, we're going to have E plus 4. Comma 1. And we have a vertical asymptote at x equals 4 that also shifts. Now E plus 4, E is 2.7, so that's 6.7, comma 1. It's just like that. So you just use your transformations, understand how logs work. And domain range. Yeah, for log graphs, domain is x is greater than 0. 0 is not included because you can't take log of 0. And the range is all real numbers. For this one, it's now from 4 to infinity, 4 not included. And of course, negative infinity to infinity is our range. Exponential functions, by the way, like y equals e to the x. Domain is all real numbers. Range is from 0 to infinity, unless you do a shift, and the range could change. Okay. It looks like that's an alert. Looks like something happened in sports. The Blue Jays beat the Royals. That's great. Okay. Looks like we are all set for this video. Okay. I'll see you later. Goodbye.